right, all right. Thanks everybody for coming. My name's Caleb Smith. I'm the Director of Research Intelligence and Analytics at the University of Michigan Medical School. I'm going to talk to you today about what I'm calling Pathfinder, which is a really beta level prototype of a new approach that we're taking to kind of blend quantitative analysis with narrative sense making. That's becoming more and more important, particularly here in the US, where we have pretty clearly left the post-World War II bubble of funding science and that paradigm. And we are really being asked to defend scientific programs in a way that we're not used to, I think, from the academic level or from the sponsor funding level. So as institutions, either funders or universities or individual labs, are asked to articulate the value of the work that they're doing, the broader impact of the work they're doing, in a really existential way, with a very real risk that funding will be removed. We haven't trained scientists to speak like this. We haven't trained administrators. We're not used to it. So I think it's an area that we, as an industry, have failed to properly communicate the value and importance of the work we're doing to a non-expert stakeholder group. Those could be politicians, those could be just members of the public who are funding our funding agencies. And this is an opportunity for us to really reevaluate the purpose of science in the modern world and how we can demonstrate impact to groups of stakeholders that don't understand the value of basic research, fundamental research. Often it sounds nonsensical to non-scientists. Why are you studying zebrafish? What does that have to do, you know? But we need to be able to say, in 20 years, this work that sounds ridiculous to you underlies this work, which underlies this work, which results in the pacemaker that your grandpa just had installed that you really do care about, right? So we need to be able to make that argument, but we also have found ourselves in this position where people don't trust experts anymore, right? So we can't just make the argument and say, trust me, I've got 2 PhDs. We need to make the argument in a way that it can be validated by non-experts. So I can't follow on and tell a case study or a personal impact story and then ask people to trust me because of my reputation or my career history. They need to be able to validate. They won't validate it most of the time, but having that option available so that it can be reproduced by different people, the same narrative, the same value we derive from quantitative analysis, can it be recalculated at a narrative level? And so that's the project that we've kind of undertaken with Pathfinder. A lot has changed since we started this. A lot has changed since I wrote this this presentation a month or so ago. It's very much in flux because we're really learning what the value of narrative is and what narrative means in this context. So I'll go through a little bit of that as I go through the presentation, but bear in mind this is very early work. My goal for being here is to solicit interest in maybe collaborating on this as it goes forward. I have some really new ideas of how narrative impacts can be automated largely. But I think we need case studies, we need examples, because there's a lot of stuff that sounds really cool, but actually isn't useful. And I think we want to really focus on utility here instead of just novelty. So with that aside, this is what we're going to go for. What we're going for are narratives for a variety of different situations: policy, general public communication, science communication, and like university writing, tenure and promotion packages. All these reasons exist for narrative articulation of research impact, whether that's personal impact, lab impact, or institutional impact. But it needs to be reproducible. The same way all science needs to be reproducible. If I make an impact story, I make a claim, especially quantitative claim, you need to be able, the reader, needs to be able to trace it back to the underlying evidence. So how can we reconcile these two things? And that's where we're going today. The overall evidence backbone that I'm going to present is kind of up on the screen. We're going to take additional or initial foundational topics in the form of individual papers. That'll be our basic unit of analysis. As quickly as possible, raise that up to the SciVal topic level. So we want to get out of individual papers. If we're talking about stories of impact, we want to immediately go to topic level discussion because that gives us stories of impact more rapidly. If we try to follow the impact of an individual paper, we're talking about a 50-year story. And that's not really going to resonate within the career lifetime of an individual researcher. We need to track them up to the research communities within which they participate, and then tell the impact story of that community. So we can say, my work is fundamental or helping this group, which is used by all these different areas. And I'll get into more detail there. From there, we need to figure out this concept of an evidence ledger. I'm calling it here a citation packet. But for whatever it is, for every narrative we generate, we need a reproducible ledger of all the reasoning we took to generate it. Think of it like a lab notebook for these research narratives. It's way too burdensome to try to create a lab notebook for an administrator who's trying to write story after story after story. So how do we automate that process so that we're not getting hallucinations in the multi-doc summaries that we're producing, but it's actually still usable and auditable. And then from there, we're going to make a chaptered brief, a narrative brief specific to the individual audience. This is where we're going through a lot of evolution and a lot of change now, but I'll get into that. And then finally, the downstream impact of how does this impact governance, how does it impact policy decisions, and just broader utility. This is another area of exploration and discovery. Okay, so here's the primary tension. When people are asked to evaluate scientific impact, research impact, they're really given two suboptimal choices. One is the quantitative story. That's where we get into citation numbers, benchmark rankings, this type number of papers, everything we're familiar with, these proxy measures that we participate in because they're available. They're reproducible, which is the big story. I mean, super useful, but they rarely show how the prior work was used. There's no sense making in what these citations mean. Are they all coming from the same research group who's citing each other? Are they coming from other groups studying different problems, which means something qualitatively very different that I'll get into. And it doesn't really help non-experts make any sense of what's being done. So, right, it tells us here's a nice measure of academic interest, but not necessarily downstream impact that I could feel. Does it actually encourage human thriving in any way? We know that other people are citing it, but we don't know for what purpose and that kind of thing, just at least on the numbers. The other alternative is the case study. And that's where we see that a lot when we're talking about institutional impact, when we talk about impact of translational science, these types of things. We look at in biomed, which is my home, if we look at the history of translational science, which is the study of translational research, it's just replete with case studies, individual case studies of individual institutions, how they've implemented something, and what the result was. The problem there is they're very rarely reproducible. There's a lot of human interpretation and inference that goes into them. It really is a kind of, I don't know, historical fiction type of thing. It's a lot of liberties are taken to tell a story. But there's no audit log, there's no lab notebook to go back and validate it. A lot of times it's built on proprietary data that nobody else can reproduce, that kind of thing. So we got to figure out a way to blend these things. Meanwhile, the people that actually care about these programs, that are, we'll call them our non-expert public stakeholders, policymakers or whatever, they're really interested in what work was used. So what did I fund that contributed to whatever this outcome is that I'm measuring? How was it applied? To what end was it used? Who else is using it and to what purpose? And why did it matter for what came next? So yes, I studied my zebrafish model and it resulted in X, and it was used by this other group studying pain perception in whatever context. But then what happened? So none of those things are really answered by the metrics only approach, and rarely are they answered by the case study approach to a really defensible degree. So that's the decision context of today's talk. Okay, before I get into the method, I want to get into the building blocks. Research communities, I'll refer to that a lot. In SciVal, they're called topics, but I like to think of them as conversations between research groups. If you imagine how science is organized, when we think of citation behavior, not disciplines, but actually what labs are working on, researchers are really organized around difficult to solve problems. They can participate in multiple problems across their career at any one time, but really what they're doing is they're trying to solve problems. I'm trying to solve pharmacological transfer across the blood-brain barrier for diffuse intrinsic pontine glioma. That's about what, if you think of like a review article, that's about, yeah, super appealing title for, yeah, my example. If you think of the scope of a review article is about the level that we care about, and the theory behind that is from Thomas Kuhn, the philosopher of science, and he kind of set a scientific community or research community is a group of about 100 people who are all focused on solving the same underlying problem. They agree on the definition of the problem. They agree on the importance of the problem. And that's pretty much what the scientific landscape is built at. It's hundreds of thousands of those groups, those little labs. That's what's represented by SciVal's topics. There are about 94,000 of them. I round up to 100,000 of these groups. How do we define them? Do we use language? Well, that's frustrating. If I use the term translation and try to group a scientific group around that word, I'm going to get humanities, I'm going to get biomedical researchers, I'm going to get computer scientists doing translational large language models. I'm going to get engineers, all kinds of stuff. Everybody uses the word translation in different ways. I'm going to get power transformers. So we can't really use language. We can't really use key terms for the same problem. They're really sparse, and people use them in different ways. So another way to do this is to use citations. And that's what Elsevier does. That's what SciVal does, is looks at how do we cluster these communities based on how they cite one another, because that's how they exchange information and truth between one another. So, I mean, this is not exactly how Elsevier does it, but the way I like to visualize it is to say, Chris writes a paper. He has 20 citations, 20 references in his paper. I write a paper. I have 20 references in my paper. 18 of our references are the same references. We're probably talking about the same thing. So that's how these citation clusters are built out. The in group, what I've circled here, is just more tightly coupled. They cite one another more frequently than they cite anybody else. If we go back to Kuhn and we say we need roughly 100 people within each of these topics, we'll set that. We get around 100,000 communities. And that's been vetted over many, many years with direct interviews with researchers and everything else. We know that these topics are really solid. We know they make sense. Okay. So that's the background of where we start here. And this is really where the focus of bibliometrics has been since Eugene Garfield started ISI back at, which is now Clarivate and everybody else, many, many years ago, and to try to figure out and make sense of science. And it's the fundamental question when you say, what am I good at? We'll define what the it is first. What is this body? And it's this research community is what we've kind of converged on as a bibliometrics community. Okay, so just enough to say these topics is the important thing. That's the key of this whole method. Now, when I say we focused on research topics for the last 40, 50 years in these clusters of communities, how to make sense of them, that's true. The same way we focus on a department, we want to know the problems that people are working on. What's become apparent now as we talk about utility is it's not necessarily the problems themselves that are interesting, it's the connections between them. So if we think of researchers, this all came about, really, we were thinking about it with COVID. So COVID-19 vaccine comes out, and I was doing a retrospective of where did this vaccine come from? Well, in like 1959 or something, mRNA was discovered. And then we look at who cited that paper. Well, mostly people working in that same mRNA community. Same conferences, same groups, that's great. That's what we would typically consider incremental science. But then there's another community that's citing it, and they're focused on lipids. Well, why was that? I'm looking in this paper. Well, this group found out that if you take raw mRNA, free-floating mRNA, put it in a petri dish with a cell, and then put a fat wash over it, the cell will absorb the mRNA and start following the mRNA's instructions. Super interesting. Okay, so that's how you get mRNA from one species into another species cell. And that was interesting because, yeah, whatever. And then down the stream, we have another group that's studying nanolipid manufacturing. Look into that. Well, nanolipid manufacturing is a great way to get these kind of fat washes into the context of a vaccine. At the time, people were trying to figure out, well, can we inject raw mRNA into a mouse brain, and then will the mouse cells start behaving like rat cells, which is where the mRNA came from? Okay. Then we go back to mRNA studies, then go back to nanolipid production, and eventually we wind up at the COVID-19 vaccine 60 years later, whatever it happens to be. But there's no clear instruction, no clear pathway that was followed there. So when we're talking to non-experts, non-scientists, the typical view is that a lab gets the football of discovery and then runs it to the end goal, and it becomes a product, which is not the way it ever works. Where it really happens is somebody makes a discovery, somebody else uses that discovery for some other purpose, somebody else uses their discovery for some other purpose, and 59 years later, it becomes a vaccine, which nobody originally set out to produce. And so I started thinking about this. Well, why? These are all different groups, very insular groups. They don't know about one another. They go to different conferences. They publish in different journals. They don't review each other's papers. Why would you ever cite somebody who wasn't part of your own community? I think in science, that's because they have something to offer. They have something that's useful for my own work. I mean, we're all fundamentally selfish. We want to solve the problems we're interested in. If somebody develops a tool that's going to help me solve that problem, I want to use it. Now, we know that there are a whole lot of ceremonial citations and all this kind of stuff. So we put a threshold on this that said, if a paper cites 4 different works from an external community, a community other than their own, that's a meaningful dependency relationship. There's something that they're citing that makes sense. So we look at this, we say, if a community has cites at least 4 papers, each paper cites at least 4 different papers from a different community, there's a meaningful link, and we add those up. And so now we can say, this community is producing something that this other community is using in a completely different context for completely different purposes. In my mind, that's the literal definition of translational research. That's translating information or knowledge from one area in one context to a different area or context. And that was the kind of fundamental insight that led to Pathfinder. And it explained the winding, circuitous route of the COVID-19 vaccine and really every other device or intervention or therapeutic that's ever come out of science. It's transferred to many different groups and happens to produce something useful in the end. So what this gives us, though, if we operationalize this across Elsevier, SciVal's 94,000 topic areas, is a directional network of dependency relationships between research topics. Because they're directional, because references happen after the publication of the original paper, you can start thinking of this as a story. So if we think of a 4-step, 5-step pathway, you could say research community 1 exported knowledge, exported discoveries to research community 2. Now we can summarize that. We know what was exported and we know what imported it. So we know the what and the why of that step. We can use the magic of large language models to summarize that and say that's chapter 1 of our research narrative. Now, from research community 2, they exported to research community 3. Summarize that. That's chapter 2. And in that way, we can construct in a stepwise way a story of translation from basic to applied. Okay. So how would this work in reality from an analyst first click to a board ready deck is, first of all, we choose what we care about. Is an arbitrary collection of DOIs, of papers. They could be for an individual, they could be for a unit, they could be all the papers that cite a particular grant. The idea is just to say, I want a starting point. Like, what is the corpus of my original story content? Now, from there, we use SciVal to say, what research topics do these publications belong to? We inspect every paper on that link. We don't care what the topic is about. We care about what the papers between the topics are about, what's being used and what's using them. Then we generate our chaptered brief, and then we ship it in a PDF, a PowerPoint, or whatever to our audience, whether that's the communications department at the university or the president who's going to approach a philanthropic organization and look for money, or a annual report to a sponsor who wants to know what we've done with their money in the last year in a way that they can understand it. What it kind of looks like is we get a narrative output, and then with every claim in the narrative, we cite the paper supporting that claim from that community to community linkage. This is what's really important. This is what separates this from a fiction story to something that's actually useful from an administrative or policy perspective. We'll say, why does this matter? We're going to cite what the researchers themselves have said in their abstracts or their papers about why this problem matters. Often they'll cite disease burden statistics. They'll cite individual case studies or problems that have been exposed and what led to this in their abstract or their introduction. Then we'll go through each step of the chapter and cite the publications that have informed that description. And then why does it matter to a policymaker or something like this? Again, we'll reference a disease burden, or you can look at something like Overton reports and cite it back to these policy documents. Again, we include an evidence ledger for all of this that maintains every claim and every citation so that it can go back and be audited by the government or by a researcher, by administrators to say, where did this claim come from? What was the citation? What area in the document was cited? I want to look at it. So it's incredibly important that we validate that. Any wrong citations, any hallucinations, just AI slop, and the whole report will be immediately discarded. So here's kind of what it looks like. In this case, we did it for a group called Caswell Diabetes Institute at the University of Michigan. And understandably, they're focused on diabetes. So we took all their publications that they had produced in the last 2 years, I think 3 years, and put them into Pathfinder. What Pathfinder did is created a column of all the research communities, all the topics that these papers belong to. One of the top topics by a number of papers produced by our group was this group studying continuous glucose monitoring. So this is a research community. The underlying theme of the research is continuous glucose monitoring. Then we look at who's importing the publications from continuous glucose monitoring. The number one link, the most links, was to this group, Type 1 Diabetes Exchange for Quality Information Collaboration. What they were doing is they were citing, so we look at the link, we figured out what's being cited and why is it being cited. And what it was is essentially this QI collab group is making recommendations for treatment or making recommendations for adoption of new discoveries. But then the big export from this group was in a group studying diabetes-specific anxiety. So we look at that, and we understand from there that 4096 was the community. They're producing stuff that's saying clinical trials, is primarily clinical trials community. They're saying continuous glucose monitoring is extremely effective in diabetes, type 1 diabetes management. So it's cited by the type 1 diabetes group. Diabetes-specific anxiety is citing it and saying real-world application is not nearly as effective as the clinical trials. So what's going on? And so in those papers, what they're finding is people are wearing this. This is largely in a pediatric context. So kids are wearing these monitors. You've seen the continuous glucose monitoring, and they're being bullied at school for wearing them. So they're taking them off. So they're not using them the way they were used in the clinical trial. So there's one, we got efficacy data that says this is fantastic, it's a game changer, real world impact, it's not being used very effectively. Well, and then the next group says, why is that happening? What is this? I should say diabetes-specific anxiety. The why is it happening was the bullying. It was also people had not been, these kids had not ever seen real-time continuous information about their glucose levels. And that was generating a lot of anxiety about just whatever. And then diabetes distress followed on from that and said a lot of these groups were socioeconomically disadvantaged. They didn't have wider parental support structures to teach them how to cope with this kind of increased anxiety, with kind of the bullying that they were getting at school. The parents themselves were getting anxious about the continuous information they were getting. So it kind of goes down into social support is what this wound up in, is the way to make continuous glucose monitoring effective. It was a really interesting story from a diabetes institute because it starts for like the science and then moves to social interaction and community outreach, which is an area that we never get into and the NIH rarely funds. So now we can make this argument about real world impact, how it kind of went from a basic area to community outreach to a really kind of regionally specific community outreach program in Detroit. Just from looking at the citations between these research communities. And the big advantage here is everybody that has SciVal has the same information, has access to the same data, so it can be reproduced over and over. Okay, that was stage one. We can produce these stories, and then people said, well, that's cool, but sometimes I know the end and I want to know how we got here, right? I know we've just created a device and we want to publicize it, but we want to show the history of that. COVID-19 vaccine was good, like a retrospective. And then somebody else said, we know the first publication and now we know what has been invented, and we want to know the pathway between those two. So we don't want to just start one area and look backward. We don't want to start one area and look forward. We want to start in this bounded area and look at all the different pathways that contributed to the eventual outcome. Okay. And then somebody else says, well, I want to know my personal market. Who's using my work and for what purpose? Because then I can target my publications, I can target my researchers, my research to who it's going to benefit the most. How can I make my work as useful as possible? And then we have a group that says, I'm working in this area, I want to work in this other area. How do I get there? How can I go from group to group? How can I traverse the translational pathway to change the direction of my career? This is a mid-career faculty. So we had to invent all these other different modes in there that aren't just strictly storytelling, but are rather like a map finding. I'll dig into this one in particular, describe the research goal. And what this happened, how we do this is we take the researcher's publications, we put them in, and then we have the researcher write their statement. I want to go from tracing inflammation in animal models of obesity to biomarkers for at-risk children in cardiometabolic disease. We score all the SciVal topics in a semantic graph. And we say, okay, what topics match that query? And then what's the directional relationship between all of them? So we can get a starting point, intermediary steps, and final steps. Usually the person wants to know the quickest possible path, but sometimes it could be, I want to find the path that uses all University of Michigan faculty. So I want a University of Michigan faculty member present in each of these nodes that I can collaborate with so I can get there. Semantic matching is what I just talked about. And then we think the pathfinding, we try to find the strongest, shortest paths, but we rank them so that researchers can look at each one and say, okay, this one looks like it's relevant to me. This one maximizes utilization of Gates Foundation funded research. Or this one maximizes utilization of NIH. Somebody I've got experience with. So if you think of it like a Michelin map, I'm in California, I want to wind up in New York. I know to do that, I'm gonna have to go through a variety of different towns. It would be best if I have friends in each of these towns to help me get to the next one. I might know how to get to town number 1, but I don't know how to get out from town number 1 to town number 2. I need an expert in town number 1, a guide to take me to town number 2. So ideally, I want to find people at my university or in my network who inhabit these towns who can help me traverse. And that's how we kind of rank them. The result looks like this. We get the we take that argument, we take the text, and create a kind of mapped pathway using the SciVal topics. In this case, we start with continuous glucose monitoring. The intermediate step is type 1 diabetes exchange. The next step is diabetes anxiety. I must have changed examples midway through here. So, but what it goes down to is other discovered paths that the researchers can explore. You know, the first path eliminates type 1 diabetes exchange from that. And they can look at them and get an explanation of why this path was chosen and how to explore it further. I talked about this really briefly. Oh, yeah. Okay. I talked about this really briefly, but what we kind of break this down to is chapters. So instead of focusing on the nodes, like I mentioned, there are 3 chapters in this translational story because it's the links between the nodes. That's each chapter. Chapter 1 is the emergence of continuous glucose monitoring, efficacy in clinical trials. Step 2, chapter 2 is implementation and social disparities. And 3 is psychosocial dimensions and support. The end point, what we're looking for is synthesis and integration in a way that policymakers and other stakeholders can understand without having a grasp of the core science. What makes this possible is that we know what papers were being cited, so we can summarize those, who cited them, we can summarize those, and then we can understand the relationship between the two. This is kind of like what one looks like that's been formatted for PowerPoint. But we get a title, we get a pathway title, we get a why it matters. This is going to change depending on the target. So we have policy papers, we have general narratives, tenure and promotion packages, but the why it matters will depend on the group that we're targeting. And then each chapter is written in language, intends to be written in language that they can understand. So that's relevant to that group. And is suitable for that group. So if we're talking to general communication, we want to keep it at roughly 8th grade reading level without sacrificing scientific precision. So some things like a procedure or a drug, we need to follow that official name. We don't want to change acute kidney injury to sudden kidney hurt. But then sometimes we don't need to do that. We can really simplify things. And in those cases we want to do, but what we want to do here is make it repeatable. And then we go chapter by chapter by chapter. Each claim has at least one reference, and then we get a full references cited at the bottom. At the bottom here in the bottom right corner, you can see these are the pathways that we've modeled so far. Policy brief, donor report, technical description, investment for our tech transfer groups, for a new grant, Center Institute grant, translational stories, etc. The idea here is, can it be good enough for a narrative brief, but strict enough for an institutional audit? That's the ultimate goal. And so we have a working system for this right now. But a lot, is still in flux as we figure out what people actually use. Okay, so actually, I'm going to stop. I'm going to open it up for questions. You can talk to me after this. I'm happy to talk more about this, to show examples, to show a demo, and talk about where we kind of changed course and what seems to be resonating most with the institution right now. Maybe I'll answer that in the questions, but yeah, feel free.
So I have about 1 million questions, but to start, the chapters.
Yeah.
I know you're starting with specific scoped use cases, but are the chapters based on the full corpus of the SciVal to make those connections?
Yeah. So we use all, however many 244 million publications, and then what we look at is the topic that just gives us really waypoints. But then the citations, we look at the individual papers, and we break the individual papers that make up that citation link into 2 things. What was cited, what was provided by the exporting community, and what cited it. And that tells us what that link is. We don't even care about the source community. One of the biggest communities in SciVal is neural networks or something. I can't remember the name of what the community is, but what we found is there are like 5 major exports, and I'll forget some of them, but this group is a computer science group. One of the big exports was using their discoveries for drone target acquisition, okay? So a military function. Another group was looking at for facial recognition for like public surveillance. Another group was looking at it for cancer detection, radiographic imaging. Another group was looking at it for aesthetic taste. You like this red dress, you might like this blue dress. Really wildly different use cases of the same source community. But if you're a funder, if you're NIH, you're really only interested in one of those. If you're the Department of Defense, you're only interested in another one of those, you know. So it really allows us to target down instead of funding topics to fund who's translating from those topics in really specific ways. Same for hiring, retention, all that kind of stuff.
If I can, one more. I literally could talk to you about this for hours. Have you looked at, and I imagine it is not as useful, have you looked at all, just out of general curiosity, at the topic clusters and the relationships, or is it, I understand, I watched a talk of yours from, I think, 4 years ago on back pain.
Okay. Yeah.
And so the logic all makes sense. And is there any use case or value at the topic cluster level from your perspective, or is that too broad to really be actionable? It's
interesting. I think at present there isn't, but I think we're moving in that direction. So I think that the topic level is really useful for a planning perspective and for portfolio planning and maybe starting new projects at a group like DARPA or you know, these groups say, what topics do we want to bring together to get performers and academics together and work on this particular thing? But as institutions move more and more into portfolio level management, I think it is interesting, and especially at the national level, where we say we want to enable science or we want to use AI to help improve scientific performance or whatever it happens to be. It's really advantageous to understand what's going on at the cluster level, and it's really these clusters are useful like structures. Like you think of them as like and topics for that matter as well. They're like towns, and town to town connections. Sometimes there's a highway, sometimes there's a train, sometimes there's a little goat path, and sometimes towns have never been connected, like toenail fungus and breast cancer, right? There's no road between those two towns, so it's going to be really difficult to traverse that, almost probably impossible. And so maybe we can avoid that. You know, that's something that we can remove from the opportunity space. So as you're trying to optimize your portfolio or the people you work with or make yourself useful, I think as we move as a society away from the pursuit of novelty and more toward the pursuit of utility, this is going to become more and more and more important.
Thank you. Have you tried to use this as a prompting for collaterals like notebook, LM, podcast, or infographics to make it affordable for all kind of public?
Yeah, so that's a great idea. No, I mean, what the limit I've used so far has been when we use this for kind of strategic portfolio management and try to identify research platforms within the institution level. We'll put the entire SciVal portfolio in there and then look at the links between them to say, like, how do different departments overlap in their interests and their goals for the future. That might be a strategic priority for us to emphasize investment, recruitment, and retention around. And the LLM, Notebook LM, those kind of things are great for synthesis to like a leadership level of like, how can we quickly do this without reading 2,000 abstracts, you know? But no, I haven't, and that's a good idea. I haven't thought of that.
Any other questions for Caleb?
I think one in the back.
So let me make a point, so general point about measuring impact from for the biomedical fields, which is easier to do so than for mathematics, for example. So based on a study, some study we did at the UCSD sponsored by Elsevier, we found attaching the patient-related matter will really help enhance public understanding. For example, we did a case study in colorectal cancer. What really happened is that they had this delivery, but there is some resistance for that chemical delivery. So you have to overcome that resistance. A lot of research happened. So what I was thinking is that in general, if you can attach for every turn, if you can attach certain human story coming from a patient,
Yeah.
that will really help.
I think you're absolutely right. And I think that's a big struggle that all these institutions have right now is the cost to produce these kind of stories is insane, right? You're paying the hourly salary of doctors, the hourly salary of leadership. So these stories are coming out to $25,000, $30,000 a piece. Can we lower that barrier and at least overcome the blank page problem? It still needs to be talked about. I mean, another example is to classify these topics, biomedical topics, to ICD-10, and then look at the actual disease burden that your region is serving, and then look at the map between disease burden, which is kind of like, we'll call that in market terms, we'll call that demand, and your research portfolio in that space, which is your supply. And is your supply matching your demand for your region? I think that's going to be increasingly important in the United States, which is what all I can speak of, where we're getting more into regional funding, regional specific funding instead of universal prestige funding. So yeah, I think that's a great point. Yeah, tying it to something personal, something, I don't know, somatic is important. Yeah.
Great. Any other questions for Caleb? I think, Caleb, you were trying to round up some collaborators.
Yeah. My goal here is to develop something super slick that Elsevier will develop, and so that we can all benefit from it. So what I do want to talk about is, I mean, with anybody that's interested is, we can set up demos of the system that I've got so far, which is not for sale or anything, but you can at least see what we're doing, as well as this kind of like personal impact story. We've done a lot of work with DARPA and other groups telling the impact stories of programs. But these same techniques can be applied to individuals, so researchers can start to use them. I know who's citing my work directly in my own field because I go to the conferences and I talk to people like that. But what we found at University of Michigan, for example, is our mycology department, microbiology, mycology department, publishing stuff that was being cited by our anesthesiology department. It was psilocybins for drug-resistant PTSD treatment. The mycology department had no idea that their work was being translated by the anesthesia department in the same university because they don't publish in the same stuff. They don't do it. Making those kinds of connections is really cool, and I think that's the future. It's not this kind of disciplinary holdover of the Renaissance, which is about teaching science. But when we start talking about solving problems, they're all multidisciplinary. It's always multidisciplinary. And it's really about these narratives. How can you explain it across different boundaries of terminology?
Just a comment. Specifically in Latin America, but I know that maybe in Africa also, there is a increasing desire to showcase the impact, and nobody knows how to do it. Okay, because the proxies are so expensive, they are so difficult to find. We all know about that. I think this method is very interesting to have all the advantages, benefits that you said, to make the showcase for national assessment, for national capabilities, regional capabilities, and we were talking about 4G, fourth generation universities. This is a way to easily, with the things that we have right now, to showcase that kind of impact and how this historiogram or histories actually regarding what is happening with the research could be easily seen.
Yeah. And translating across different domains with different terminology. I mean, these large language models were originally created to translate, right? They were developed by intelligence to translate. They're really good at translating. And we've played around with translating between specialties, right? Describe this material science to a dentist. You know, I mean, how do you do that? Or describe this dental function to a car mechanic. It's like WD-40 for your teeth. You know, whatever happens to be. These types of translations are possible, and they're super important. I mean, the hardest part of entering a new field is the years it takes to learn the terminology. And so, yeah.